Lesson 2.1, Multiplying Fractions. In this lesson, you will learn how to multiply fractions and mixed numbers. Key idea, multiplying fractions. In words, the task is simply multiply the numerators and multiply the denominators in order to multiply fractions. In numbers, it would be represented as 3/7 times 1/2, the numerators 3 times 1, and the denominators 7 times 2. And then completing the multiplication, 3 times 1 is 3, 7 times 2 is 14, so 3/7 times 1/2 is 3/14. Written algebraically, if A over B times C over D is the problem, you're going to multiply A times C and B times D, where B and D, the denominators, cannot equal 0, and that's because you cannot have 0 as a denominator. In example 1, multiplying fractions, they're asking us to find 1/5 times 1/3. In multiplying fractions, then, we're going to take the 1/5 times the 1/3, and we're going to say that's equal to the numerators, 1 times 1, over the denominators, 5 times 3. And then completing that multiplication, 1 times 1 is 1, and 5 times 3 is 15. So 1/5 times 1/3 is the same as 1/15. Example 2, multiplying fractions with common factors. This time we're asked to find the product of 8/9 times 3/4. Again, if we write that out, 8/9 times 3/4, we're going to multiply the numerators, 8 times 3, and multiply the denominators, 9 times 4. Before we go any further, though, this time we're asked to find some common factors and divide those out before we multiply. In looking at my numerator numbers and my denominator numbers, I see that I have a 4 and an 8, and I know that 4 is a factor of 8. 4 goes into 4 one time, and 4 goes into 8 two times, so I can divide that out. Since I'm dividing both the numerator and denominator by 4, that's the same as dividing it by 1, which doesn't change our value. And I see that I have a 9 and a 3. 3 is a factor of 3. It goes into 3 one time, and 3 goes into 9 three times. So again, I'm dividing both by 3. 3 over 3 is the same as 1, so I'm not changing the value of my fraction. And now I can multiply 2 times 1 is 2, and 3 times 1 is 3. So 8/9 times 3/4 is the same as 2/3. Example 3, real-life application. You have 2/3 of a bag of flour. You use 3/4 of the flour to make empanada dough. How much of the entire bag do you use to make the dough? So basically what they're asking us is to find 3/4 of 2/3. And to do that, we would need to multiply. 3/4 of 2/3 tells me of is to multiply, so it's the same as 3/4 times 2/3. And if we follow the key ideas from the last slide, that means that I'm going to say 3 times 2, multiplying my numerators, and 4 times 3, multiplying my denominators. The next step is to find common factors. I see there are both 3's on both the numerator and denominator, so dividing by 3 over 3, I would have 3 goes into 3 one time there, and 3 goes into 3 one time here. And then 2 and 4 have a common factor of 2, so I can divide by 2 over 2. Dividing 2 by 2, I would get 1, and dividing 4 by 2, I would get 2. Now I have 1 times 1 is 1 on the numerator, and 2 times 1 is 2 on the denominator, which tells me that how much of the entire bag do I use? I use half the bag. Another way to do this problem is to show a model. If I drew a model and I said this was my whole bag, and I'm told that I have 2/3 of it left, so I'm going to divide it into thirds. And I have 2/3 of it left, so I have this much of it left. And then it says I need to use 3/4 of it to make the dough, so I'm going to divide it into fourths this direction. And I'm going to use 3 of those fourths. 1, 2, 3. So I am using this section of the bag. If I look at how many squares I have altogether, I had a 3 by 4 rectangle, 4, 8, 12 squares, and I've colored in 6 of them. So 6 out of the 12 squares I colored in. And that has a common factor in both the numerator and denominator of 6. 6 divided by 6 is 1, and 12 divided by 6 is 2. And there again I have the same answer, 1/2. I used 1/2 of the bag. Another key idea deals with multiplying mixed numbers. Write each mixed number as an improper fraction, then multiply as you would with fractions. So example 4 asks us to multiply a fraction and a mixed number. Find 1/2 times 2 and 3/4. 1/2 is already a fraction. To get 2 and 3/4, that mixed number, into an improper fraction, remember you multiply the denominator by the whole number, and then you add the numerator. So 4 times 2 is 8, plus the 3 is 11, over my same numerator, 4. So now I have 1/2 times 11/4. That's the same as 1 times 11, multiplying my numerators, and 2 times 4, multiplying my denominators. I don't see any common factors there, since 1 and 11 are both primes, so I'm just going to multiply across, and I will get 1 times 11 is 11, and 2 times 4 is 8, 11/8, which is still improper, and it would be best for me to get that back into a mixed number. So 11 over 8, I can take out 8/8, which would give me 1 whole. And if I take 8/8 out, that leaves me with 3/8 as a fractional part. So 11/8 is the same as 1 3/8, which is the product of 1/2 times 2 3/4. More practice with multiplying mixed numbers in example 5. Find 1 4/5 times 3 2/3. First step is to make them both, those mixed numbers, into improper fractions. 1 times 5 plus 4. 1 times 5 is 5, plus 4 is 9, so I have 9/5 for that mixed number. And 3 times 3 is 9, plus 2 is 11 over my 3 for that mixed number. I have 9/5 times 11/3. My next step is to multiply my numerators, so I have 9 times 11 on the numerator and 5 times 3 for the denominator. Next step is to look for common factors. 11 and 5 are both prime, but 3 is a factor of 9, so I can take 3 divided by 3 would be 1 here, and 9 divided by 3 would be 3. Now I can multiply across my numerators. 3 times 11 is 33, and 5 times 1 is 5. That's an improper fraction, so I should simplify and get it back into a mixed number. There are 6 groups of 5 and 33. 6 times 5 is 30, which would leave me with 3 left over 5, so my answer is 6 3/5. Example 6, real-life application. A city is resurfacing a basketball court. Find the area of the court. First step is to remember that the area of a rectangle is the length times the width. In this case, our length is 21 1/3 meters, and our width is 13 1/2 meters. Getting these mixed numbers into improper fractions, I would say that 21 times 3 is 63, plus that 1 is 64/3 meters. And 13 times 2 is 26, plus 1 is 27/2 meters. I could then say 64 times 27 multiplying my numerators and multiplying my denominators 3 times 2. I know that 2 is a factor of 64 because in this 1's place here I have an even number, so 2 divided by 2 is 1, and 64 divided by 2 is 32. I also know that 3 is a factor of 27. Thinking back to my divisibility rules for 3, if the sum of the numbers is a number divisible by 3, 2 plus 7 is 9. 9 is divisible by 3, so I know that 3 will go into 27 9 times, and 3 divided by 3 is 1. Multiplying across my numerators now, I'm going to rewrite it so we can see a little better. 32 times 9 as my numerator, and 1 times 1 is my denominator. 32 times 9 is 288, and 1 times 1 is 1. Thinking back to what we know about fractions, any number over 1 where the denominator is 1 just gives us that numerator of 288. And thinking back again to area, we know that when we multiply meters times meters, we get meters squared. You can write that in one of two ways. You can write it 288 meters squared, or you could write 288 square meters.